We've now arrived at that point in the program where we will hear the annual report of the IBL centers. That report will be presented, as always, by Dr. Ron Douglas. Ron earned a Bachelor of Science degree at Illinois Institute of Technology and the PhD under Pasquale Porcelli at Louisiana State. Both degrees were in mathematics. Ron has held every rank from research instructor to professor of mathematics at the University of Michigan. Been a professor of mathematics and held various administrative positions at the State University of New York at Stony Brook, and been professor of mathematics, provost, and executive vice president, and finally distinguished professor of mathematics at Texas A&M. He has led the IBL Centers project for the Educational Advancement Foundation almost from its beginning. As he always does at this conference, today he will bring us news on developments at the 5 centers. Let us welcome him. Ron.
Thank you very much, Lee. As you know, this is the 15th legacy meeting, and I was not involved in the first 5 or 6 or 7 of those. I can't remember exactly when. But this group came together and had these meetings basically to remember and to honor the memory of R.L. Moore. About 5 or 6 years into that, having these meetings, people started thinking, we should do more than simply remember or honor. We should, in fact, actually try to foster, develop, to encourage the kind of teaching he was known for. In other words, and what we're now calling IBL. So about almost 10 years ago, 5 universities were chosen to host centers or projects which involved the development and the encouragement of inquiry-based learning. And these 5, as I think most of you perhaps know, and some of you have heard this many times, some of you haven't, Chicago, Harvard, Michigan, Texas here, and UC Santa Barbara. The purpose of these centers was to, as I said, to develop, to encourage, to experiment with, to provide incubators for some of the kinds of activities and some of the things that we've been hearing about. For example, the assessment and evaluation project that Sandra has been reporting on now and reporting on for the last several years basically used at least 4 of these universities as the incubators or the test places to interview students, interview faculty, interview instructors, and so forth. In other words, these were the places where she sought the interviews. This was her test subjects as far as that was concerned. And that, I think this has been a very important role that the centers have played from this point of view. Another role that the centers have played has involved the dissemination, the workshops. There have been workshops funded by the NSF in Austin here a couple of years ago, in Ann Arbor last year, and there'll be one next week or something, very nearly at Santa Barbara. Other kinds of activities like that have also been fostered by the centers in terms of dissemination is concerned. Another activity which you've heard about here that more or less came out of these centers, or at least people talking about these centers, is the ABLE, the Academy for Inquiry-Based Learning. Although formally separate from the centers, it certainly in spirit and in idea and in foundation comes out of the centers. The center, the kinds of activities, as exactly what I've reported on in the past and what people have reported on in the past. In other words, a lot of new courses are being taught, new courses are being taught, new courses are being developed, notes and directed readings and textbooks even have come out of the center activities. And rather than reporting on those in detail like we've done in the past, we decided last night, in fact, that rather than repeating a lot of what we've done right here, and I apologize for the people who haven't heard that before, but we also recognize that you can go to the websites of all these operations, these projects, and get an even better, more complete, up-to-date report on what's been going on. And I don't have I'm not going to try to put up the web addresses, but you can go to the EAF webpage, and there will be links there to all of these, so you can get even more information as far as that's concerned. So what we did decide to do was we would take this time to basically interact with you and basically tell you a little bit more about, ask you for advice as to what we should be doing, what we could do. Now, I mentioned, for example, the workshops. If you ask, in other words, the people, the graduate students, the postdocs, the young instructors that have gone on to other places, and even undergraduates that have studied at these 5 places over the last almost 10 years now, that probably means there are something between 100 and 200 and perhaps even more people around the country that have experienced IBL in the sense that they have some idea what it is. Many of them know how to teach it, and many of them, in fact, are teaching at the universities and colleges where they currently are. So, in fact, that's been one, I think, important contribution that these projects or these centers have made, to the ongoing operation or the evolution and the development of IBL across the country. As I said, the workshops is another one from that point of view. So what we're really talking about is the center activities have influenced literally hundreds of people, and directly or indirectly are influencing what's happening in IBL at a lot of colleges and universities across the country. What I'm going to now do, instead of continuing, as I said, a more detailed report and calling on people, what I've done before is Paul Sally nearby here? In other words, Paul agreed to be the next person. This is kind of going to be a tag team presentation, as always. Is Paul here?
I have to confess that my hearing aid battery died this morning, so if you want to talk to me, you have to come up and yell in my ear. But I can yell in yours in the meanwhile. So Ron was recounting how this all started up north, as they say. These people came riding up from Texas and told us they wanted to do this stuff. Of course, they were at Chicago when they came in, and there was the R.L. Moore's photograph somewhere on the wall in the basement. And so we get into this, and I just want to say a couple of words about our experience and our hopes for IBL and I would say our quest for directions in some sense. Everybody here is directed. Everybody is thrilled IBL works, IBL does this, IBL does that. Well, first of all, I don't know what your experience has been, but every time I teach any course anywhere, and I've been doing it for over 60 years, I learn something from teaching the course. No matter what level the course is, whether it be kindergarten kids or whether it be a graduate school course, I learn something new from my thinking about the course. But when I teach an IBL course, I learn a lot more new things because the kids in the class have fantastic ideas, or I might say the teachers in the class have fantastic ideas, or any other audience you might address. What I want to promote here is the idea that, hey, IBL is great in universities, it's great in this or that class, and so forth and so on. IBL is meant to take over American education. And here we are. We are the pioneers, we're the apostles, we're the representatives, and we have to find ways to get it into every imaginable situation that we can think about. And when is that going to happen? Not tomorrow, but it's got to start to happen soon, and we need a lot of existence proofs. That is, we need various projects in every aspect of mathematics education that will allow us to tell whether IBL is the correct way to work. I believe it is. And so do all of you, otherwise what would you be doing here? I would say, however, that in various circumstances, the approach to IBL cannot always be the same. I'm looking for new ideas, how to approach IBL. Is it to present a script? That's the first thing we did at Chicago. We taught honors calculus. I did it with Diane Herman, and we called the course Public Humiliation Calculus, and it was a rousing success, and I learned a lot of mathematics. The approach, I had taught honors calculus, 40, 50 times, but I learned a lot of new ideas about the subject. Since then, we've expanded in a variety of directions into our Young Scholars Program for mathematically talented kids who are unstoppable and bursting with ideas, correct, incorrect, and otherwise. And I've done it with Chicago public school teachers, and I'm doing it now with a group of kids from the toughest ghetto schools in Chicago. How am I going to work IBL with them? Haven't figured it out yet, but there's got to be a way. The kids have to get up to the board, and they are scared silly to move. They are used to being talked to by people who don't know what they're talking about. So it's not an insuperable barrier, but it's something that we have to attack. The other thing I would like to say is that when we do IBL mathematics, it's always good to do the mathematics correctly. It's an unusual idea. I was just had David Brissou's ear for a moment, and he gave this great talk yesterday about what's happening to calculus in the country. So my question for him is, how many people use the mean value theorem to teach the fundamental theorem of calculus? Because you can't prove the mean value theorem without using you can't prove the fundamental theorem of calculus without using the mean value theorem. Not one, no question. It wasn't a question. All right, so is that correct mathematics to teach calculus without the proper properties of the real numbers? It's something to be decided. But what I would say is if we introduce IBL, it's not for the purpose of getting people up to talk about mathematics. It's for getting people up to talk about correct mathematics. So as we move along, we have to make sure that at every level, with every audience, the mathematics is good. So what are we doing in Chicago? Well, I've started to outline some of it. We'll probably write up some notes soon. But the idea is to spread it into every venue of American mathematics education. Teachers are now in desperate fear of the Common Core Curriculum state standards in mathematics because there are examinations coming down the road in 2014, and people don't have any idea what to do. We seize the opportunity. IBL, will it solve the exams in 2014? Absolutely not. Is it the way to pursue a new road in mathematics education? Absolutely sure. But what we have to figure out is a variety of ways to approach it and make sure that we don't always pursue exactly the same track or pursue the script in exactly the same way. You have to adjust to situations, and then we'll see where we get in another 15, 20 years. Stay with it. Thank you.
I'm going to look for somebody else that's supposed to be up here, and that's Mike Starbird. Are you around? Okay, here's the mic. I'm going to hand it off to you. You're going to be the next person.
Well, okay, so I will stand and pose this question. And I think maybe I'll use the metaphor that Sandra began, which is the guiding of a ship. It seems to me that this is at the end of the conference, and we should view the progression of history. That we're thinking about where we were and where we're going, and a lot of the discussion has been about where we are, and a little about where we were, and so we decided that one of the things that we'd like you to turn your minds to now is where we're going. And what kind of influences should be used to steer the ship? You know, the question of trying to actually change what's going to be different in 20 years from the way it is now in American education. That's what Paul Sally was just talking about. He said, well, we're not going to be able to change it by 2014, but the question that he posed was, how are we going to make the influences that are going to continue to push the change in direction of the ship so that, in fact, we do arrive at a good destination, or maybe avoid the iceberg? I'm not sure. If we think of the Titanic, we should maybe avoid the iceberg. But the point is that what we would like to do now is to ask you, what is it that we can do? That is, what can this project do? What can the centers do that is of most influence to the potential positive future of this this project of getting better methods of changing the lives of students and better ways of instructing them and thinking better, how can we improve that in the most positive way? What influences would you like from us? For example, if you yourself are new to IBL, what were the influences that brought you to see this method of instruction as a positive thing? And what more could we produce, and we being all of us in this room, but particularly the centers or other people that are, we're in a position, a wonderful position, to say what kind of influences would be most effective in changing the minds of you or maybe your colleagues who are not convinced. What kind of materials would you want? What kind of assessment would be important? So what we'd like to ask you to do right now is to talk to the people at your table and to give instruction about what kind of activities you would like to see brought to bear to turn the ship in the right direction. Does that make sense? As a charge to you for right now or not? Why don't we go ahead and try it, and if you all are just floundering, then we'll try again, okay? So the question is, what do you think would be, if you were in charge of the Educational Advancement Foundation, if you were in charge of the National Science Foundation, in trying to figure out what to do to influence constructively American education, what would you have those entities do?
Let me interrupt just 1 second. Mike has indicated to me that this is a written assignment. In other words, you're supposed to write something down, so we're going to ask several people or several tables to respond, but we're also going to write something down. Doesn't have to be long or anything else, and we'll collect those and use those as, as homework, or actually classwork. Just a couple more minutes. Okay, I'm going to I'm going to now go to various tables and ask for a report of what you've thought. So I'm going to pick this table over here, which has got a lot of people and a lot of activity. Who would like to be the spokesperson for this table? So here's the ideas from this table.
No, you're just going to hear my opinion if you give me the mic. Okay, I'm Lee Mahavier Peterman, and Ron made the mistake of giving me the mic because now you're just going to hear my opinion because I did all the talking. No, Sam Young from Auburn University is here, and he said that he thinks we should get rid of the standardized tests. And this gentleman, whose name I've forgotten,
Tom,
who is from
Arkansas, Little Rock.
had a suggestion on how to get rid of the standardized test, and I didn't hear it, and it was?
I'm not sure what it was.
Okay, so we have a very shy table here. And then I was saying that, in my opinion, since we've heard several times that we all teach the way we were taught, and that's certainly true of me, that we should have more, in the pre-service teachers should be taught by more method. Therefore, they would go into their classrooms when they become teachers, and they would teach by more method. And the last thing we said was, remind me, Sam? Oh, you were concerned about discipline in the classroom. That's another story.
Okay, thank you very much. Let me go over to a different table. And we're happy to hear suggestions for the whole educational operation, but anything that the centers could do or would be fine.
You can just tell us about what you were telling us. Okay, so one question I have that Oh, my name is Nina White, and I'm at University of Michigan. One question I had for the panel yesterday, but it didn't quite seem applicable, was I had specific questions about pre-service teachers and the difference in IBL courses for pre-service teachers when it's not new material, it's not a proof sequence, it's not something they've never seen before, it's material they've been seeing since they were in kindergarten. How to do that in an IBL setting? It's because you can't have them rediscover fractions because they already know what fractions are and they already have all these preconceived notions of what they are. And so how IBL looks different when the material is not new at all, it's the exact opposite. So that's something I was wondering about yesterday.
Let me go on to a different table. Who would like to speak here? Ideally, although questions are interesting, ideally what we're looking for are directions either for everybody or for the centers in particular. Who would like to take the mic?
Okay. I'm Don McClure, American Mathematical Society. A facilitator, Rolf from University of Michigan, came over to our table, and I turned the tables on him and asked him, why is it that what the University of Michigan is doing in teaching calculus has not spread more widely to other large publicly funded universities? For example, is it used at other universities in the state of Michigan? It seems to me that when there's an example of something like that that is demonstrably working, it should be supported and should be transported to other universities that have to address the same challenges.
That's a good question. Of course, that's one that the NSF struggles with a lot of the time. So they fund programs and come out and various tests and everything else declare that they're successful. Then they go on and do something else. Let me come to this table over here. Who would like the mic in this table? You don't have anything?
Somebody over there does.
Where? Okay, well, fine. I've been following the precept of calling on the table that has done the
I think we need to encourage more communications between colleagues about students, like sometimes even in different campuses or the same campus. Like my colleague will tell me this student is better in visualization or better in homework or take-home exams. Another thing, I think if the EAF can work on, put an influence on the curriculum itself. Let's be realistic. If I want to do a right IBL, I can't finish all the material, for example, in college algebra. It just can't happen with the students we teach. So maybe another description of a course specifically taught by IBL that will have maybe less content so the students can concentrate and then we have more time to do activities. Another thing that we talked about, maybe workshops going towards realistic scenarios. Like, you know, to be realistic, no one of us, I think, can do complete IBL and finish the whole material. I do IBL and I call it hybrid IBL. I can't finish everything if I will do right IBL. It's just I can't. I tried it many times, considering, you know, the levels of the students that we have. So if we can produce more workshops towards realistic scenarios, this course may be for pre-service teachers, this course is for mathematicians, for honor courses, and so on.
Okay, thank you very much. How about, got another hand? Sorry.
Rob Kirby from, retired from Berkeley. I actually wanted to respond slightly to Don McClure's question of, you know, what Michigan is doing something, why aren't other places doing it? Well, Berkeley, which I'm familiar with, of course, has been hit by budget cutbacks and so on, and we don't feel we have we can't run calculus in small classes. But what we do, there's a lecture 3 hours a week, but then there's 3 hours with the TAs. And the TAs, I believe, I haven't actually watched very many of them, but I believe they're doing something like IBL in that section. The students come, they give them a worksheet, they all sit down, and it's up to 25, and they sit down in the classroom, and the TA walks around and talks to them and so on. That's something like what the rest of you are doing. And on the other hand, there's no direction for this. I don't know if the TAs are being told anything more than what I just said. So there's certainly room for progress there. The other question, this is a question to the rest of you. Is there anybody in this room from Math for America, Jim Simon's project? Is there anybody here? Yeah, so there's a well-funded program with lots of mathematicians involved, and they should be learning from you. They should be hearing what you have to say, and maybe they'll be here in the future.
Thanks. Let me head over. Got somebody?
Hi, I'm Brian Katz. Our table was discussing, from Augustana College, our table was discussing communicating with colleagues who are uncomfortable with the idea of IBL. So I think it would be really helpful to do a national study of the concerns that people who are who are uncomfortable with IBL, what they're concerned with, and then obviously following that up with an attempt to collect data to respond to the things they're concerned with. And the final product being something like sort of a double-sided sheet of paper that's written in a way that communicates to someone who doesn't have IBL experience what it is and addresses those results. Particularly, I'm thinking about a friend of mine from Project Next who had a really negative response from her colleagues, and she got another job. She had to leave that department because she didn't have, I think Carol knows who I'm talking about. We weren't successfully able to jump in and provide the support she needed to communicate with them.
One of the questions that Mike asked, and you can respond to it, was how you came to IBL, in other words. And you might want to say something about that. Let me come over to one of these other tables. Is there anybody here that wants to say something, or I'll come to this table here? Yes, no, I see you. I'm getting there.
Regina Gravey-Jackson from Auburn University. We talked a little bit here. We have a very small table, but one of the things we said is more well-designed experiments. A lot of the people that you're talking to are people who really respect research. That's where they're used to seeing things. So the more results they see, the better they are to accept it. And I thought about the way that I was brought in. We talk about we want people to teach the way they were taught. Well, and pre-service teachers, that's good, but a lot of times we have GTAs who are going to be teaching. So I think that the way that I was brought in is I was on an outreach program that brought IBL to the K through 12, and getting more GTAs involved with bringing IBL to other places is a good way for them to experience themselves as well.
Thank you. Anybody at this table here? What?
We need to rethink calculus and think, as mathematicians, think how to get a setting for a rational discussion of the subject. The old dx, dy stuff is not adequate for a rational discussion of calculus. We need another notation that's not just for indoctrination of people, but for a rational discussion. That's probably the highest priority.
Thanks. Well, I'm coming over this way. I'll come back.
I'm Martha Siegel from Towson University in Baltimore. And I think one of the problems, and I don't know quite how to address it, but our CUPM curriculum study is supposed to be addressing it, is the linearity of the math curriculum. That is the build of prerequisites upon prerequisites, which makes experimentation very difficult for people caught in the middle of that sequence. And in particular, some people have asked me, well, when do you cover sequences? We do it here. Well, if you do it here, then you can't teach probability right after Calc 2, okay? You have to wait till Calc 3 or something of that sort. I don't know how to attack that, but I think it's an idiosyncratic issue for each department to make this kind of decision, but they need to make it in the context of how they're teaching their courses. And furthermore, we cannot expect everybody to teach the same way. So we really need to think in an open way about the curriculum at the same time that we're thinking about how we're delivering it.
Thank you. Let me come over to this end of the room. Who would like to? I was going to get them coming back, but that's okay.
My name is Vinton Geisfeld. I teach at the International School of Minnesota in suburban Minneapolis. I've been teaching for about 40 years, and much of it was very frustrating. I would concentrate on the perfect explanation of the material, only to find 2.5, 3 weeks later how little the students actually got. And I think one of the principles of changing behavior is to get relatively immediate feedback. And I think that one thing that teachers could do, or an exercise that schools could put their own teachers through, would be to have them teach a topic and in the hour immediately after that class, have the students take a test over it. I think if anything would convince them of how poorly the lecture system works, that would do it. Once we've then established the need that the lecture system isn't in fact working, and it isn't a function of just how well explained it was, that it in fact isn't working, then when they can try, maybe in the immediately following class period, doing the same content through an IBL approach and test it afterwards. I think you need to establish the need for changing before people will actually make the effort of doing the change.
Thank you. Who at this table would like to talk?
Hi, I'm Joyati Debnath. I'm from Winona State University, that's in Minnesota as well. My experience with IBL was when in my childhood, I had my high school in India, and I did not know, or I don't know if teachers even knew what IBL or this kind of thing is, but we were constantly put up on the board. We had to stand up on our seat and we had to recite in front of the class, or we had to say the answer, and teachers didn't even want to think what our feelings are about this. It's not like whether you are put on the spot or not. We were on the spot. I mean, if the teachers think to be put on the spot, we were on the spot. If we couldn't answer the question correctly, we had to stand the rest of the class period. That's like a punishment. So there was no choice. There was no choice, and that's how I learned. And so when I teach the way I learned, but of course I couldn't do that kind of punishment. But I just had to, in my class, I just had to tell them, this is, it's a deal between you and me. When you paid the tuition and you signed up for my class, you gave your soul to me. And I'm going to do the best for you, and you, if you are unhappy today, you will be thanking me later. And that's how I'm doing it. And some people really, really like to be in my class. They will wait for me to teach some upper division classes. And then some people who doesn't want to speak in the class, they wouldn't take me, but that's okay. You know, you can only make difference in a certain way. You cannot make difference little by little. You take a little step at a time. So I would encourage everybody not to be afraid. I had my tenure and promotion and everything, so will you. People will see the difference, and then people will stop by in your office and will say, okay, how do you do this, Joyati? You know, what do you do? Okay, can I talk to you for a minute? And you will see that you are making a difference. So I'll encourage everybody to do if you think that's the right thing to do.
Thank you. How about somebody at this large table here?
Hi, my name is Catherine Beneteau. I'm from the University of South Florida. In terms of things that centers or NSF might support, there were a few things that came up at this table, some of which Jill and I were just whispering to each other after our conversation time was over, and some of them that already came up in the classroom. So one thing was the need for evidence and the need for data. And so to support research like the talk we heard today, research on the effects of IBL and student learning, I think that's very important to a lot of mathematicians, that students are learning the concepts in a correct manner. On the other hand, we did talk about the fact that people have been teaching their whole lives a certain way with lectures are not likely to change. And so I'm just echoing what some of the other people said, the key of supporting young people, so supporting graduate students who are going to go then and postdocs who are going to go and be faculty members at institutions and have a big effect on their departments. So those are sort of change agents, and also teachers. So someone had mentioned the pre-service teachers, so training those teachers to in sort of a variety of methods. And so the training is very important. So I feel like workshops that really provide training for graduate students and faculty are really key. And then also echoing what came up at the table over here, the need to develop curriculum that gets widespread. So everybody here, and I know the IBL website has curriculum materials, but developing coherent curriculum materials that other people can use. So, you know, you talk about teaching a course with the Moore method and you come away with all these ideas, but how do you actually go and do it then in your classroom? You email someone who was at the conference and you say, give me your stuff, right? And give me ideas. So the need for really developing coherent curriculum that can be disseminated, I think, is important.
Okay, thank you very much. Let me come up front here. There's one of the questions that came up in a number of the conversations is the one about how do we support, how do we encourage, how do we provide backup, if you like, for people that want to teach IBL, either people that are currently doing it or people that would like to do it. And I mean, the last thing we heard here had to do with curricula being developed, being tested, and so forth. We've in fact got various, the ABLE website, the Journal for IBL, there are a number of places where this is being provided for you, and I'm not sure it's as well known as it needs to be, not necessarily this crowd, but the larger community out there. Another question comes up is this one about evidence. In other words, Sandra was talking about this experiment or this study that she made over, and you shouldn't underestimate just how much work was involved, and it wasn't cheap. In other words, it was several $100,000 in order to do something like this, and it took 3 years of a lot of people's time in order to do something like this. I'm not suggesting that it wasn't worth it. I think it is. But what I'm saying is it's not so easy to do those kinds of studies. One question I've got, which we've kicked around, is the following. You've heard her presentation. She is in fact prepared, her group is preparing various research articles for the math education literature. Most of our colleagues, the ones that we'd like to influence as far as teaching is concerned, do not read that literature. I mean, some of you do. I mean, it's likely that there'll be an article or two in the notices or in the monthly or in various other places like this. But the question, I guess, is what is the best way for us to disseminate that information? In other words, provide information. I mean, one of the other questions related is the following. In addition to Sandra's study, there's a whole lot of other studies that have gone on, not necessarily specifically in mathematics, but in science, having to do with discovery learning or active learning or inquiry-based learning. And one thing that we've been kicking around is the question, does it make sense for us to try to foster or to try to find support for a meta-study or an analysis of the various studies here, and then present that in some sort of a pamphlet, a book, or something on the web, or whatever. In other words, would that be effective? In other words, the question is, if you say, in other words, especially if you're someplace where nobody is teaching using IBL, and you say, go in and say, I'd like to do it, in other words, then the question is, what would you want to tell your chairman or your colleagues? In other words, how would you like to marshal support for what you're doing to show them that this is not such a radical idea, that this is not crazy, that lots of people do it, and in fact, we know that it works. So that's a question which we don't know. As I say, we've been toying with, and we don't. The feedback doesn't necessarily have to come from during this hour now, but more generally. And in fact, I'm going to go on a little bit further and simply say that I think this has been an interesting conversation and discussion. And in fact, I think we perhaps have a few more minutes, I'm going to ask for hands from the audience want to say something more. But what I'm going to say is that this conversation and this discussion does not have to end here. In other words, you all have in fact, you've got the email address for everybody, for the conference. But you could also have an email address either to send it to EAF or to send it to me or to Paul Sally or Mike Starbird or the other people at in other words, but one of us as to what the suggestions might be. Now, this is not going to be a democracy in the sense that the most votes that tell us to do this is not necessarily direction we're going to go. But the point is that it would be useful to have more information, more discussion, the views of more people. When Mike stood up and started elaborating on Sandra's metaphor about the ship, one of the things I was thinking about is if you're on a ship, when you start out, it's very easy to see the port behind you. In other words, it's when you go into open sea, however, it's more than a little scary. I think we can still see the port. And I think the open sea ahead of us is a little scary. On the other hand, I think we've come a long way as far as what we've been able to do over the last 5-10 years, partly because of the centers, partly because of the enthusiasm and the contributions of a whole lot of people here and a lot of people, in fact, that aren't here. Let me ask, in other words, I say we've got another 5 minutes or so. Is there anybody that'd like to sort of try to summarize? Yes.
Thanks, Ron. Hi. I'm Greg Foley from Ohio University. I wanted to let folks know that the National Science Foundation and U.S. Department of Education are having a K-16 mathematics education initiative. And there's a Dear Colleague letter that Joan Farini-Mundy sent out on May 14th. You can find it at the National Science Foundation website, nsf.gov. And the publication number is 12-080, NSF 12-080. Till July 1st, you can have an influence on how $60 million of federal funds will be spent for K-16 mathematics by putting in your views there. As far as outlet for information about this, the Notices Doceamus is something that people should write articles for, people in this room. So everyone should send their ideas to the National Science Foundation and not just to Ron, because there's this one-shot $60 million joint NSF U.S. Department of Ed initiative that you should influence.
Thank you, and absolutely. In other words, if you send things to me, in other words, I'll just be the middle person as far as that's concerned. But let me expand just a little bit more. In fact, the notices, as most of you know, the notices of the AMS has a column which is an educational forum. If you did not see my article on IBL, I think it was the April issue, or either the April or the May issue, I encourage you to take a look, not because it's so well written or anything, but simply because I've said a lot of the things perhaps better there than I've said up here. But what I'm mentioning it for is to encourage you, other people, to write similar things. In other words, it is a lively place. A lot of the people we'd like to influence, in fact, do look at that and do read that. There are other outlets like that in the monthly. In other words, there's articles that one could write about this in terms of, I think your experience, when you're going to write something, you're going to have to say something a little different, or something, a different aspect or a different take on one of these things. But starting a lively conversation, a discussion within the community on IBL, I mean, I think by now, especially with Sandra's results and everything else, one can back up what we've always believed. But I think it's perhaps time for us to somewhat become a little more aggressive, or to get on the offensive as far as this is concerned, and in fact provide support for the people that would like to do this. Is there anybody else that would like to say anything more before we stop, before I hand this back to Lee? Okay.
Thank you. I'm Paul Zorn from St. Olaf College, and happen to be serving now as the Mathematical Association of America president. I'm really speaking in the former capacity. principally. I just wanted to underscore the importance of evidence in this discussion. I think from a mathematician's point of view, there are at least two kinds of evidence. There's the sort of proof sort of evidence, which many mathematicians, I think, perhaps mistakenly demand for any kind of educational innovation. They'd like there to be a proof that something really works and is perfect. That may be too tall an order, but the example kind of evidence is actually very well respected among mathematicians too. And I think it's really crucial that there be defensible examples in a variety of categories of IBL approaches to various courses. So for instance, I think my colleague over here just left, but he mentioned, for instance, the challenge of teaching a course in an advanced subject like, say, complex analysis, while using IBL methods, but also really getting to, say, Rouché's theorem. I'd like to see an example of that. I don't doubt that one exists, but I think that I'm not alone in among mathematicians in wanting that sort of evidence. So I guess my takeaway message is evidence and examples as a very good form of evidence, documented examples.
Thank you very much, Paul. That reminds me of something about 1990. I don't remember the exact date, or in the early 90s. Alan Schoenfeld, who is a math educator at this point, but started out as a mathematician, wrote an article, which I can't remember exactly where it appeared, but it wouldn't be too hard to find it. It basically indicates all the reasons why the kinds of proof that Paul was talking about at the beginning is almost impossible in this subject. And I don't mean just for IBL, but I mean just generally. There was controlled experiments. Well, it's hard enough to do any kind of controlled experiments involving people. But what one has to do is one has to look at the kinds of evidence that Sandra's been presenting, which I think is compelling, but also the kinds of things that, I mean, what one knows in many areas of our public life especially is that one antidote trumps all the data in the world. And that might be something that we could use. Often you're at the wrong end of that problem. But in this particular case, I think we have more than a few good antidotes where the antidote has to be provided and described in sufficient detail for one to understand and respect it. But I certainly encourage us, as I said, to not just the people that are in the centers, but everybody, to basically write articles, to argue, to present evidence, and we will try our best, to provide the kinds of support that we can provide. Anyway, thank you all very much.